Hi, I'm Jesse Vincent. Let's see. You might know me from GIFT, our web framework, RT, the ticketing system lots of people use, including Perl and CPAN. I don't know, other stuff. Oh, I'm the Perl 6 project manager, which I think may mean that it's all my fault. Anyway, today I'm going to be talking about building domain-specific languages in Perl. I do have a tendency to talk fast, and even although my slides are in the Takahashi style, I have a lot of them. So if I'm making no sense at all, look at me very confused, and hopefully I'll get the hint that I should slow down. How many people here are familiar with domain-specific languages, DSLs? Do people know what they are? Okay. So DSLs are basically little languages. They're a way of expressing some programming task in a way that makes sense for us, but only for that specific kind of task. Generally, they're a little easier to read, they're a little more expressive, and it's about optimizing the code for being able to work with it and for being able to express what you need to do very succinctly and very easily. Mostly, I'm going to be talking about what I call Englishy DSLs, things that read like the English language. I understand that that may not be the perfect topic here in Asia, but hopefully it makes some sense. Not all DSLs are Englishy. Yesterday morning you heard Mark, and yesterday afternoon you heard Audrey talking about DSLs, things like SQL. SQL's a DSL, regexes, Excel macros. XML configuration files are a particularly twisted and wrong DSL, but they are a domain-specific language. XSLT is a language designed just for transforming XML. GraphViz. GraphViz is a language just for expressing how graphs get built. But Englishy DSLs are the thing I've been into. They can either be implemented in your host language, so they can be sort of internal DSLs. They're things that are, so all of the things I'm going to show today are pure Perl. So they, in fact, there are no source filters. There's no parsing and compiling of some other language like Mark was showing yesterday. You can also have things that are outside your host language. So a DSL where what you're doing is parsing BNFs, Bacchus-Noor forms, for how to actually build up protocols and things like that. Those things get called external DSLs. That's not really my thing. They're not as easy to introspect from your host language, and I just don't like them as much. Everyone probably knows that the Ruby community is very big on domain-specific languages, particularly Rails. You can build up these things that are gorgeous and easy to read and very expressive and say exactly what you're trying to do. It is possible to do the same thing in Perl, even though it sometimes hurts a lot more. So how did I sort of get talking about all this? Where did this come from? And of course, I just ruined the next couple slides, but so how did I get here? I took an airplane to the Narita Express, to the subway, and it all started at OSCON 2005. David Hansen, the guy who created Ruby on Rails, got up on stage, and he started talking about Rails migrations. It's the little domain-specific language that Ruby on Rails uses to transform your database on upgrade. Let's say we added a column called password to the users table. We added a new table called foo to our application. They were really, really, really sexy. They were pretty. We had nothing like them in Perl. And I got jealous. And then he said the thing that you shouldn't say. He said, you can only do this in Ruby. I picked Ruby because Ruby lets you do these gorgeous things that no other language lets you do. That's not what you're supposed to say when you've got Perl hackers in the audience. So we've made some DSLs. The first one is GIFT-DBI schema. This is a DSL for declaring database schemas. When I saw Rails migrations, nobody ever told me it's only for migrating, and that it's not, and that you still have to start off by hand coding SQL. So I didn't actually ever read the manual when I built this, and I figured, oh, well, this is how you build out all your Rails database stuff. So I'm going to do something just like that. So GIFT-DBI schema actually encapsulates the entire database model, from all the columns when you start, each column you add in a new version, columns you remove, changes you make to the database schema. because it's what I thought Rails did. It's what I thought Rails should do. So that's what we do. We've got one for web templating. Yeah, it's another templating system. But this one really, hopefully, will bring some closure to the whole thing, and you'll see what I mean in a bit. And we've got a DSL that we built for simple web testing. It is so aggressively not ready for prime time that I almost didn't put it in the talk. It's something we're working on right now. It's something that I sort of want people to see and comment on and tell me how it feels. But because it's so beta, that means that it's got to be right for Web 2.0. So we're going to talk about GIFT-DBI schema. And I'm going to start by talking a bit about our design process. Because when you're building a DSL, the most important thing is to figure out what feels right and feels comfortable. In the Perl world, people mostly figure out, well, what kind of information do we want? We probably want an object-oriented API on this, and then they build this thing that requires you to write pages and pages of garbage. It's still nowhere near as bad as Java, but people don't think about the aesthetics. What should it look like? How should it feel? And so we spent probably about a month playing with syntax and not really thinking about, can we implement this? We started with DBIX Search Builder. Search Builder is the object relational mapper that RT is built on. It's kind of like class DBI or DBIX class, but it's actually been in production longer. It's in use at tens of thousands of sites around the world and powers large processes for lots of people. But in Search Builder, columns were defined as a big hash. Hashes are really, really not very pretty. And so we played around. We were looking for what feels right. And after we found out what felt right, we started thinking about, is that even possible? So the design process that we went through was a bunch of text files. It was a bunch of IRC sessions. And we have them all sitting in our repository to help remind us of how we got there. So what I'm going to be showing next are some snippets of just thoughts people had. Some of them we don't even know who said them. But it was just sort of like, what should it look like? So we start off, should it be that you create a schema builder object and then you call methods on it? That's very sort of standard Perlish. But what we really, maybe we wanted something where it just sort of feels more like simple definitions. There are fewer sigils, there's less garbage. And there's something in here that's actually a little bit hard to do. And this is sort of where we started to run into trouble. So this takes this field name and then a block of code. In Perl, you can't have a block of code as the last argument to a function. It can only be as the first argument. So, but we weren't really thinking about that yet. And in fact, well, we did start thinking about it, and people started arguing. And well, maybe we could use a hash instead of a sub block, and maybe we can play around. Maybe we can just get a block that has nice declarations. So you start by importing things in a scope, and then the scope goes out. Then the $s variable gets destroyed and can garbage collect. How can we make this pretty? That technique is actually really close to the technique that we ended up using in the end. So very early on, we actually came up with some clever ways to make things work that weren't necessarily what, we didn't know where we were going. Maybe it's something like this, sort of more standard Perlish, where it's calling methods. There were some questions of how do we get all of our magic functions loaded and unloaded. We could hide them and attach them to some other method that people have to call at the beginning of a piece of code. Maybe we could just tie ISA. Or we could tie the simple table. People have tried. You can't do it. If anyone here can tie the symbol table in Perl, I'd like to talk to you, because it will allow you to perform acts of great evil. Maybe it's something like this. So we're going to do some kind of importing, and then we can declare our table and field blocks. And then we were still sort of stumbling over, should it be a sub, should it be a hash? We don't really want it to be a hash. I was big in favor of this has type blah, is this, is that. And Glasser, one of my engineers, was, well, a hash is okay. Hashes are, they're reasonable. You don't get some of the interesting behaviors of when code gets run with hashes, but they could work. And And then we got to the really tricky one. We wanted to be able to say, this column refers to this kind of object by this attribute. So how can we make that go? Well, we could play stupid parsing games, and we could, in fact, actually just have that be a big string that we could parse. And so I said this to Audrey. Robert says that this is impossible. When you've got a smart Perl hacker who likes a challenge, the best thing to do is to tell them, you can't do this. And someone else in the community says it's impossible. That was how I got Simon Cousins to actually write a piece of code that uses BD parse, or that uses the B backend to remove myself equals shift and magically make shift an appropriate lexical variable. I said, Chromatic says this is impossible. When you tell a good Perl hacker that something is impossible, well, it happens. But so anyway, I said this to Audrey, and knowing full well that I was probably going to lose. And now I'm definitely going to lose because I can't hit the... So anyway, Audrey says this about 3 hours later. You can just inject methods. And once you've injected methods, you can get this gorgeous syntax, and you can inject a method within a given scope, so it can go away at the end. But suddenly, you actually have this syntax, and it parses as valid Perl. And so really, we were still running into this field equals sub issue. Basically, we wanted to play with something like that, and we just couldn't quite get there. This is, that first thing actually ends up with it being a hash, as does the second. It's not quite right. We played with things like this. In the end, we ended up with that. It's simple, it's readable, it's relatively, it's writable. Perl tidy does the right thing with it. When you're building a domain-specific language in Perl, if Perl tidy does horrible, horrible things with it, it's not worth doing. Mostly because developers will keep hurting themselves. But it's simple, it's declarative. We're fairly happy with it. Use GIF DBI record schema. What this does is this basically calls GIF DBI record import on the schema function, which takes a block of code. So that gets evaluated at use time. It instantiates all the methods. It sets up all the backend data structures. So we actually ended up implementing this DSL twice. The first time was really the first DSL we were building in Perl. We ended up with GIF DBI schema, and it really was taking a big hammer and whacking away at Perl until we made it parse things the way we wanted to. It works. It wasn't the cleanest, but so mostly we used injection of functions, which we saw a moment ago in Audrey's IRC messages, and we used clever function prototypes. So this is the syntax we wanted. We saw that a moment ago. And this is how Perl parses it. This is the default Perl parsing. So you can use this trick, Perl mo equals dparse, to get what Perl actually thinks is going on with all the parentheses and all the proper quoting. And so it actually thinks that we're calling type on the is class and passing it in all these things. And that really wasn't what we wanted to end up doing. So prototypes. Prototypes are a useful thing in Perl. They basically inform the parser of, here's what's actually going on. So we set this up. We basically said the is function takes a single thing, the as function takes a single thing, and doing this, Perl MOD parse now actually parses it like this. And we have a DSL. The big problem here is that every time you want to add a new attribute, that means putting a new function in a namespace. It's not really the right thing. So we ended up looking around for how to do it right, how to do it next time. And this is another Audrey special. It's called object declare. And effectively, it's Katamari for code. And if you look in the insides, you'll actually see that it's actually built out of Katamari objects and Damasi objects. It's all about balling up your syntax and rolling it up, and in the end, returning one useful thing. So again, this is what we've got. and this is what the parser thinks is going on. And who are we to be telling the parser that they're wrong? So what we're going to do instead is use Perl's internal rope. We've got this universal package, which every object is part of. That means that is a subclass of universal, immutable is a subclass of universal. And then we have the autoload method. The autoload method gets called whenever some function whenever some function that doesn't exist is called. So at compile time, the schema function, it takes a code block, and it ends up returning a closure. And then GIFTDBI record, its import function takes over. It takes that closure, and before running it, it installs some methods. So it installs that autoload method. It installs universal is. It installs as autoload, and then it runs the closure. And it gets all its data back out, and it hands the results off as a data structure to a method of your choice, which can then actually just take that data structure and create objects, or go out and print things, or whatever you need to do. And then it removes its magic symbols and puts the state of the interpreter back where it was. So it ends up not keeping your program dirty. It doesn't have all these magical autoload and universal symbols floating around after the fact. And then it gives control back to your program. So that's the basics of GIFTDBI schema. This talk is all about using horrible, horrible, abusive tricks to give end users pretty easy to use things. What time do I run until?
You got another half hour.
Okay, perfect. So I'm 1/3 through. So next up we've got template declare. Template declare is a language for templating. If you've seen other things, so it looks like this. This may remind you of Markaby, the Ruby-ish thing, and it may remind you, if you're a real old school Perl hacker, of CGI.pm. This is what everyone was doing before we learned that it was wrong. Except back then we were just using functions. And when you're just using functions, it's basically you call h1 and it outputs an h1. It's not so useful. But so let's see. This, in a little more detail, it looks like this. It's simple semantic markup. You can chain these functions together, and you end up with basically a big tree of closures that, when you run them, and they run plenty fast, they can generate HTML, but you can also pass them around like code. So you can do things like refactoring. But you're going to hear things like this. It's content, and it's your templates, and there's design, and they're code, and they're mixed together. That's not okay. Whoever told you that's not okay was lying to you. We're Perl hackers. We're the ones who actually end up writing the backend logic, the backend logic, and actually most of the presentation. We don't do the pretty styling, but that's not what we're talking about here. There is no reason that as Perl hackers we should be writing our templates in a language that is not Perl. In 1997, when you had to put lots of table tags in, and you had font tags with color, and your designers were constantly going in and tweaking the hex values in your templates, sure. But in 2007, we have CSS. The programmers still end up being the ones making templates in all but really the largest shops, or the ones that really aren't writing much code at all. And templates run like code because they are code. And if they're code, you should be using coding tools to build them. So here's a standard sort of thing you might do in HTML. You'd print an h1, and then you'd print a div, and the div has an attribute, and then you'd print something inside the div. And that's ugly. That's, if you're familiar with sort of the Web 2.0 way of doing things, you'll probably have heard of the don't repeat yourself principle, DRY. Why are you repeating yourself in your HTML? That should be a function that you should be extracting. And so now you just used your coding tools to extract a bit of presentation logic. And it's easy, and it's done. And this is a stupid, trivial example, but when when you're working with your templates and it's just a matter of extracting functions, then you actually end up with much cleaner templating rather than, oh, I'll just add a div here and I'll add a div there. You start pulling, it starts becoming very easy to pull individual things out. Refactoring is really a nice thing. Has anyone actually spent much time trying to refactor HTML? Was it fun?
No.
How about refactoring code? Does anyone here actually enjoy refactoring code? Okay, that's something. Other things. Because we're not using angle brackets, all the HTML is magically valid. Anything that this can output is valid running code, which means it's valid running HTML, or it's valid HTML. We can actually, as we're building our DOM, we could even warn you when, say, oh, you can't put one of those elements inside of one of these elements. You specified an attribute on that bit of HTML that's not actually valid XHTML. When you've got a syntax error, it's a syntax error. It'll actually tell you you have a syntax error, and you don't have to spend 6 weeks looking for, well, why did it, oh, I closed the div here and the span there. So we've got all these templates. Where are we going to put them? So we see this syntax. We're saying template foo index.html is a sub. So the way that gets implemented is that subtemplate takes a name and a code ref. So these just get layered into your code like subroutine declarations. It's pretty straightforward. At compile time, it parses it and says, oh, I'm going to call the template function, and I'm going to pass it in foo index.html and the sub, and then template compiles it in to a sub, and it needs to stick it somewhere. We need some kind of global stash. It actually feels so we need it per package. We don't want to like mix different packages, templates together, because actually when you've got your templates as code, you can do inheritance, you can do mix-ins. So you can actually have a base library of templates for a standard application that has a create view and a read view and an update view. And then you can subclass it and change just a little bit of it. But so we need this stash to be per package. What I've been saying basically is we need a symbol table. So we have a symbol table. We have the symbol table. So we can stash things there, except, well, you can't put a colon in a subname. You can't put a slash in a subname. You can't put arbitrary Unicode garbage into a subname. Well, Perl doesn't really care. It's only the parser that cares. And since we're basically doing our own parsing, or really walking around the parsing, well, you can do something like this. You can actually insert things into the symbol table by hand, and they just work. Even if your sub gets named something crazy like that. You can put backticks in it. You can put double colons in it. You can put all kinds of crazy shit in it. But then you run into this little problem of, okay, well, now it's in the symbol table. What are we going to do? Well, so there's, in Universal, this wonderful Universal package, there's this method can. And what everyone uses can for is can says, does this method exist? And that's just going and looking in the symbol table. But the other thing that can does is if it exists, it doesn't just return 1. It doesn't return just true. It actually returns a reference to the piece of code in the symbol table. So basically, you can use universal can to actually run blocks of code straight out of the symbol table. Should talk a little bit about that syntax. HTML tags generally take blocks of content. And our tag methods, they take blocks of, well, Perl, which could be more tags. When you need them to, they return closures. So if you actually call it in a scalar or list context, you'll get back a code ref that you can run. So you can pass that to another sub. So you can build up complex subroutines that contain blocks of template and pass other blocks of template to them. But if they get called in a void context, they will actually output to a buffer. And you can walk around this behavior when you want to, but we end up basically doing this. When an individual tag gets called, it takes a block of code. If we're not in a void context, we actually return a closure. If we are in a void context, then we're actually just going to execute a bit of code. And of course, because these are custom template packages, this is a templating language, we actually expose methods for every HTML tag. Well, all but one of them. Does anyone know why we don't expose a method for a table row? Yeah. So, Dave, I think you raised your hand in the back. Dave says, because there's already a Perl built-in of the same name. And in fact, yeah. So usually, if it's a core function, you can actually override it. You can't do that for TR because it's a deep, low-level built-in, probably dating back to Perl 1. It's all Larry's fault. But really, it's okay. There are plenty of times when you want to use tables. So we do, in fact, we expose alternate primitives for table building, and we've actually built some template tag libraries to let you do clever things with Yahoo UI. So template tags don't have to be just open a div or just open a bold element or just open an H1. They can be give me a pane on the page that's floated left. They can be give me a user widget. Give me an AJAX-y dropdown. So you don't just need to use these sort of core base HTML templates, but that's what we export by default. I think we should probably be using HTML tag set instead, but CGI.pm was expedient at the time. So there are some problems. There's some things we haven't figured out how to parse. So of course, when you're building out HTML tags, you need HTML attributes. So things like being able to say, our div has an ID of my div. So we've got two syntaxes that work, but neither of them really make us happy. The first one is it reads funny. It's okay. It's better than everything. It's better than everything else we've seen. The other one also reads funny. What I really want is I want to be able to say this. I want to be able to put those there. Some of you seem to be nodding. Some of you. So what's the problem? We can just change the prototype, right? So in Perl, the take a block of code bit in a prototype has to come first. In Ruby, I'm led to believe it has to come last. But the parser doesn't have any way to let us have something come before that ampersand. I don't know what to do. If anyone has a brilliant syntax idea, I'd love to hear it. Questions about template declare? Okay, I'll keep going for now. So in fact, I'm probably going to run a little short. Test declare. It's a language for testing web apps. This is really a new toy. This is something that we haven't even CPAN'd yet. We've built test scripts in it. We're reasonably happy, but I don't know yet. Maybe it's just wrong. Maybe everything I've talked about is just wrong, and I'm sure there are people in the audience who feel that way. But so anyway, nothing here is fixed in stone. Nothing, it hasn't been CPAN'd. The API is not stable, and we might do something different. But we're working from a simple premise. Test scripts for web stuff are really ugly. We want something that's pretty and easy to read. In effect, we want simple, easy, declarative web testing. So we're going to start with the easy to readness. And easy to write's important too. And we want it to feel like what users are actually doing when they're working with their browsers. So test mechanized, sort of the standard Perl tool for writing tests about web apps, looks like this. It's kind of a mess. But you can see that we're creating a server object. We're making sure the server started and that it is a server object. We're creating a client. We are getting a web page. And we're checking that we got to the right page. The internals for this stuff are really just fantastic. They work. They're reasonably clean. They're very robust. But the syntax is fucking ugly. So we started with the internal. We started with test more and mech, and got to test. What we have for test declare looks something like this. You've got sessions. Sessions run blocks of code. Inside of sessions, you have individual workflows. And so what happens is when you start up a session, it sets up a cookie jar, it sets up a mechanized object, and then it runs a block of code. And inside that block of code, it expects to see a bunch of flows, some sort of set of tasks you should do. Each task has a bunch of steps. And if any of those steps fail, then your entire thing, then the entire check block should fail. So what we're going to do is we're going to get this Google page, and that NCR says, no, really, I want the English page, or I want the default Google page, because if I did that from here, without that, I wouldn't find my Google search button. Google search is the English default. We're going to look for a form with name F, and it's going to have a field called Q, and we're going to fill it in, and we're going to click a button. And all those steps need to work, and that's all that needs to work. So if you've ever built web test scripts in Perl, you've probably run into this. When there's a failure, when like you say, click the link that says home, and for some reason the home link isn't there, the rest of the script starts to fail because you've lost your context. And there's no reason to run those other 20 tests that'll take 5 minutes when you know that they're not going to work. And so what we can do, what we can do is basically when we see a failure, we know that we've lost the context, so the checkbox can just abort on failure. And when you see an abort, that means that we should actually be registering a failing test. When you start up a new session, it gets a new cookie jar and a new mechanize. It doesn't yet work, but you should be able to mix sessions together in your flow. So you can say, as this user, click here. As this other user, click here. And you'll be able to just use that same session, the same session syntax to embed one session inside another session or two sessions next to each other. So you've got things like this. So in our login test session, we're going to do a basic connectivity test. We're going to we're going to try to get the fsuck.com domain, and we're going to make sure that the content has the word fsuck.com in it. We're going to click on a link called book, and we're going to make sure that the link we got to has the name of my book in it. So if any of those fail, we abort. So there was a bit of weird syntax on that page. Yes, just one bit of weird syntax. It's that. I've run into, so this is one I'm not sure about. The goal is to make it really clear that it's actually checking something, that there's something that needs to happen. We played with assert angle bracket content equal tilde this, but it didn't feel right. This sort of felt more conversational, and as you can see by the way I'm talking about it, I'm not sure about it. But the technique was interesting because I've had a lot of people look at that and say, that's not Perl. That can't be Perl. So this is what we were fighting against. This is sort of the standard thing. And if you're a seasoned Perl hacker, it's, you know exactly what this says. This says, we're going to do an OK test to see if the request content matches this regular expression. But when you're just skimming through things, or you have testers who aren't sort of as conversant in Perl, reading quickly, this one, I think, is a lot easier to understand than this. But so we run into this question of, how do we turn this thing into valid Perl? And we come back to our old friend, prototypes. Prototypes are so lovely. So we're going to work from the end. So we want to match RT essentials. So basically we have submatch that takes a single thing and returns it. So now we have, and in fact in production it checks to see if it's a regular expression or if it's just a string. If it's a string, it makes it a regular expression. So you always end up with a regular expression out of match. Should is actually a null phrase. It doesn't do anything. It's just there to look pretty. But what should does is it takes a single thing and it returns it. And then the content, if the content basically says, if it's in the full version, it does a bunch of different things based on what content is handed. But if content is handed a regex, it says, does the content match that regex? If not, die. And since we're inside an eval, that causes a failing test. And that's all you need to do that syntax. So that's what so we end up with something that's very simple and very readable and very writable. And the other thing is that the syntax isn't tied to mechanize like most test scripts are these days. So we can actually implement a different backend for this. There's a testing system called Selenium. Selenium is in-browser testing. So you actually can run scripts that talk to your browser and make it do things. Make it click on things, make it look for things, make it check the DOM. Because it's running in browser, it can actually use XML HTTP requests and do AJAX testing. And so what that ends up getting you is it gets you tests that are more like what the user is doing. So test will declare when it's fully done, you'll have this syntax and it will be able to actually run your tests both with mech from the command line and if you have Selenium enabled and available in your browser. So it'll be able to do all of these things and report back on them all at once with one simple DSL. We'll probably end up implementing that as a standard CPAN module on the back end. One of the things about building DSLs is that you should try to be careful not to tie your DSL too tightly to the functionality behind it. If you can build your pretty syntax as a layer on top of something that's OO or traditionally functional, it means that even people who don't want your pretty syntax still get all your functionality and will still contribute bug fixes, patches, documentation, and the rest of that good stuff. So let's see. So that was testable declare. We've had a lot of fun building DSLs. It can be really painful. We've spent a lot of time beating our heads against the Perl interpreter. There are a lot of really dark corners. There's lots of real serious craziness. We found more than one Perl bug as we've gone through this. But that's good. That's useful. Perl is better for us having done this, even if you think everything we're doing is wrong. But DSLs can make coding more fun. When you're writing something that's clean and simple and elegant, you enjoy it more than lots and lots and lots of braces, brackets, and semicolons. One thing I haven't seen is I haven't seen much in the way of Japanese DSLs. I would like to see some Japanese DSLs showing up on CPAN. Because the Englishy things do actually feel different than other languages. And so what makes sense as a domain-specific language that feels like English is presumably very different from what would make sense as a domain-specific language that feels like Japanese or feels like Chinese or feels like Russian. So that is the bulk of that is the talk. Though I should say I've actually been, as I've been doing this, I've been working from another DSL. When I started writing these slides, I traditionally used Takahashi.Zool, which didn't feel quite right for the code snippets. So I ended up inventing a DSL for my talk. So it's very simple. You've got directive lines that say title that will change the page title. Individual lines of text get treated like Takahashi-fied text that gets centered and turned bright blue. 5 minutes, no problem. It's really, really dead simple. Titles change. Last night, Ishigaki-san said that if he finished his slides, he would consider translating my slides for me. And apparently, this terminal isn't behaving. But if you say loc-ja, that's where the Japanese localization will be, and the slides will come up with it in yellow and black at the bottom, like a proper subtitle. If you've got a slide that is Perl code, it'll actually. So you can specify modes. Right now, we have only one special mode, which is Perl mode, and that will pass it through a syntax highlighter. And at one point, it was actually passing it through Perl tidy as well. So this is just a quick little DSL I whipped up for. I want to describe my slides and don't want to have to do any more work. I don't want to play with transitions. I don't want to play with splashy graphics. And it made my life a little bit easier, and it took an hour or two to hack out a tool that does these, and at the same time does a separate so we've got our presenter display. The presenter display is by catting text to a text file that is being tailed in another window, but it works. Oh, and the slide system can play music. It did because I didn't have an output here. I couldn't actually. It wasn't loud enough for anyone to hear. But when we got to object declare, the Katamari Damacy theme started up. The backticks are, in fact, not actually being evaluated as backticks. This is a bit of the DSL. It's what is a way to explain to a programmer writing slides a bit of code that should be run. And so it looks for a comment line that is just backticked and pipes it through open with appropriate dies and runs it. But the backticks are just it's a little DSL that feels right for me. So anyway. We've got a couple of minutes for questions or people haranguing me and telling me that everything I'm doing is wrong. It looks like Dave wants to tell me everything I'm doing is wrong.
I'd love to, but actually I have some questions instead. I'll tell you everything you're doing is wrong later. No, actually,
Hold on, share the mic.
cool stuff.
You should, Mike.
I'm not loud enough? Jeez, I've never been told I wasn't loud enough before. So one kind of question, comment, I have two. As far as the mech testing type stuff, there's a module on CPAN you might want to take a look at called Test HTTP, which was written by some folks at Social Text, which actually implements a source filter-based DSL for doing HTTP testing.
Cool. Source filters are an abomination, wrong, and should never exist.
I
but
agree.
Understood. Thank you. I'll have a look.
But the concepts might be useful. For example, it's more for like REST testing, so it'll test kind of what status did I get back, what content type, things like that could be useful to incorporate in yours.
Cool.
And the other question I'd like you to answer is why, for the first thing you showed with the schema declaration, why would you prefer that to, say, an actual language that you parse? Maybe talk about the advantages that you found.
So let me see if I can. I haven't yet implemented search in the slide side, so this is Vim. So here's one reason why a language that I parse isn't right, isn't right for me. This column time zone, one of the things it valid R takes a list, and that is a list of all possible valid time zones for this thing. So you can, in fact, anywhere here that you've got a scalar or a list, you can have a Perl subroutine or basically you can get your data from somewhere else. Also, parsers break. I only want one parser that's going to break in my programs, and I want that to be the Perl parser. Having a custom DSL that we have to hand parse means that programmers have to learn something else that isn't actually valid Perl, and their debugger won't work, even if their debugger is print statements. More questions?
あと質問もう一つぐらいなら。
Am I getting off easy? Even not related to this. Anything else? Yes. So the question is the slides language DSL an external DSL? Yes. This one I'm actually hand parsing with regular expressions.
Can you make it internal DSL?
If I don't have to give Audrey's talk this afternoon, yes. It would be interesting.
Sounds
to see.
impossible, so you can do it, right?
Yeah, maybe. I'll have to play with it. So I may have to change the syntax.
次行きますか。あとないようでしたら、one more question?
The templating language, like how far, when can we start playing with it?
The templating language, template
Yeah.
declare,
Yeah.
is part of the current GIFT subversion release.
Okay.
And the current version is on CPAN.
Okay.
And we're using it live in production for doxry.com. And we're really happy with it.
Okay, cool.
I have one quick question for you. How can people get involved and start contributing? I know you're looking for feedback on both your testing and your templating. How do we help you?
How do you help me? So certainly you're welcome to harass me for the afternoon. GIFT.org is sort of, most of the DSLs we've been building are as part of the GIFT Web Framework project. There's a GIFT devel mailing list linked from GIFT.org, and #GIFT on irc.freenode.net are both places that people can come and hang out and chatter. どうもありがとうございました。
Thank you.